Hi, I'd like to welcome all of you to today's webinar. Today we're going to be covering ADAPT Integration Console version 5, which is used to integrate between Etabs and also ADAPT-Builder. And just a few announcements before we start. The webinar should last roughly 45 minutes to 1 hour. If you have questions, there's a question panel that you can type your question into, and it will notify me. I'll go ahead and answer the questions as they come in to the best of my knowledge. If there are questions that are more specific in nature to, let's say, a model you're working on, or even troubleshooting type questions, we would just ask if we can reserve those till after the session. You can communicate with our support staff at support@adaptsoft.com. My name is Spencer Lee. I'll be conducting the webinar, and we'll go ahead and get started. So also one more thing quickly is the webinars are recorded. We add them to our playlist on YouTube. So if you go to youtube.com/ADAPT-Support, there's a playlist which is titled ADAPT Webinars, and there you can find recordings of the webinars that we conduct. So what you're seeing now on screen is the model we'll be working with, and we're going to go through roughly 3 or 4 different uses of the integration console. The integration console is limited such that it imports geometry, gravity loads, and lateral static loads from Etabs. If you were to import a load, for example, a response spectrum type of set of results or reactions from Etabs, those can be transferred into Builder, but inside of Builder, if we try to reapply them at a single level within ADAPT-Builder, the loads are not in equilibrium, so you're going to likely find yourself running into an error because of that. So right now, currently, we do support lateral static. We are working on the ability to introduce the response spectrum and other types of loadings inside of Etabs in terms of designing slabs at joints. So that should be the next iteration of the integration console, but for now it is limited. You can export geometry, applied loading. So if we have forces, either gravity or lateral, like wind and seismic, those can be transferred into ADAPT, and also internal reactions in columns and walls due to the solution from Etabs. So we'll start with looking at Etabs. This is the model again we'll be looking at. It has perimeter column as an interior core and slab. So it's a pretty simple model to illustrate the program here. One thing to note is we have to create what's called an XML file in order to transfer the applied load data into ADAPT. So we're going to start doing that. We'll go to File. I'm going to export. This has already been solved, so we'll go to File. We'll export Etabs tables to XML, and we'll go down here to the analysis results, and then we're going to select the frame results, structure results and story forces. So we want to create an XML file for the story forces. We'll say OK, and I'll change this to my units. Here we're going to use feet and, let's say, kips for the force. Say OK. That will prompt us to save the XML file somewhere, and I've already saved this file here, so we'll just override what we have. We'll say save that, and we're done. So the prerequisite of using the ADAPT integration console is, number 1, you have to have an active license available for Etabs, and number 2, the solution has to be in place. If you've only built a model in Etabs but haven't solved it, we can't extract the frame reactions. So a solution is necessary, and then if you want to import applied loads, you must create this XML file. So I'll go ahead and close the instance of Etabs, and then we're going to go ahead and launch the integration console. So let's go over here to ADAPT Integration Console. And this is the latest version. It's version 5 of the console. You can see there's different selections we can make. Both Etabs 16 and 2015 are performed, the functions are performed using the API that's built into Etabs. If you use an older version of Etabs like 9.7, then you have to create output and input files similar to what we just did for the XML file, but it's a little more involved. There's more data that has to be produced in creating those files. This is just an older version of the integration console that has been around for several years now. The latest version was released earlier this year, so that's the version using API. And we're going to be using Etabs 16 in this case. And then we also have an option for STAD integration if you have STAD models that you wanted to import into Builder. Depending on what is selected here, the different dialog windows will change and prompt the user to select different things. Today's webinar will focus again primarily on Etabs 16. 16 and 15 are identical in how the console works. So what we see in 16 is what you would see if you were doing the same thing with a version in 2015. We'll go ahead and select next. First step really is to just browse and load the model in question. Again, you have to have an active license for this to function properly. So we'll browse to the model that we just had open. I'll go ahead and select that path, that file path, and then I'm going to load the model. When I load the model, the program will, the integration console will launch Etabs and extract the necessary information. So this takes, depending on the size of the Etabs model, this takes a few seconds up to potentially a few minutes to produce the file. And at this point, the program will open, the model will open. Don't close it. Wait until the program automatically shuts down the instance of Etabs. So we'll wait for that here. Okay, so there's the same model, and now it's closed. Now, once that happens, we have the ability to determine either whether we want to import all of the levels from the Etabs model or just individual levels. One reason you might want to use individual levels is, let's say you're processing the design of a mat slab in Builder, and all you really need are the reactions at the mat, at the base of the structure. In that case, you could export only the story or the base level forces. You could apply them in Builder, build the mat in Builder, and then design the mat using the applied forces from this link. In our case, we're going to import the entire structure. So at this point, if we do not want to import the applied loads, we can directly go here to creating the ADAPT exchange file, which is the .imp file that we use for integration with Etabs, Revit, and other programs, even integration between different ADAPT models. We can use the IMP to build a new file from an ADM file. So we're going to include, though, in this case, both applied loads and reactions. So in order to import the applied loads, I have to go ahead and take this a step further and select the XML file that I had created previously. So we'll browse to that file. I've selected the file. Now I'm going to create the ADAPT IMP file. So similar to opening and closing the model, the ADAPT IMP file, depending on how big the model is, how much data there is, this can take a few seconds up to several minutes, and the program will return a message stating that the IMP file was successfully generated once it has been completed. And the IMP file, while this is running here, the IMP file will be stored where the Etabs file is stored. So in this case, I have a Builder folder just on my desktop, and in this folder, let's say for webinars, ADAPT-Etabs 2017, that IMP file will be placed in here. And so you can see there's the IMP file that's been written right there. Going back to the desktop, that is the message that would appear. So that's been created successfully. We can close the integration tool. And now we're going to go into Builder. So inside of Builder, when I launch Builder, I want to launch Builder with Edge, which gives me the ability to analyze the multi-level structure. And I'm also going to launch it with Floor Pro. We might want to rerun a single level with the reactions from Etabs in order to design that particular level. That's one of the standard workflows, I'll call it, for the use of this tool. And also we're going to include the option to import from Etabs right here. So we'll go ahead and say OK. And I'll just close down some of these toolbars, redock that, and I'll go to File, Import, Generic Adapt File, and we'll go ahead and navigate to our file that we want to import. I'll go back into that Webinars folder. Here's the IMP file. When I launch the IMP file, it's going to open the Import Options dialog window. So in this window, the user has the ability now to select different sets of information or data that need to be included in the model that will be produced from the IMP, an exchange file. So here we're going to select all. We're going to bring in the entire model that will increase the count of beams, columns, walls, whatever components you have in the Etabs model, those will be imported in here. You can merge similar slabs. So if you do manual meshing in Etabs where you might create an individual slab region for an element, let's say, and you might have 200 slab regions on one level in Etabs, this will just merge all like slabs into one slab in Builder. So this is useful. It's more useful for older versions of Etabs where some of the meshing tools may not have been there as they are now, but that is an option for import. Load cases and combos. The program will list the load case, the type of load that's being imported, whether or not you want to import applied forces and reactions, applied forces only, or reactions only. So you have the ability to select which set of data you want to be imported. For this modal load, that's just by default always shown. I'm just going to select no to that. Then we have dead, live, EQX, EQY, and then several wind load cases. Here, these are all assigned to static lateral. I will import applied forces and reactions. And then if we have, if we already have load cases defined inside of Builder, for example, in any Builder model that you create, there's two reserved gravity load cases. There's dead load and live load. So we technically can map these loads that will be imported as gravity to dead or live or self-weight. Or we also have pre-stressing and hyperstatic. We're going to choose not to map loads into this model. So we'll just directly import the information. For the applied story forces that will be imported for EQX and wind, we can determine and set the eccentricity to be used. This can be overwritten after the fact, but here you can set the percentage for eccentricity. These lateral loads are imported as generic lateral loads within the software, and I'll show you where that is once we import this. Under load combinations, the program will import combinations that were produced in Etabs, and those will be imported into Builder. So I'll import all of the combos. We've made our settings here. We'll say OK. And now the program produces the same model that was found in Etabs with all the loading. So here, by default, it's going to show columns, walls, all the different components, slabs, and also the gravity loads. The gravity loads are externally applied loads. The lateral loads in the model EQX and EQY, those are not externally applied. And if we go up to loading, load case library, you can see that the program, by default, again, ADAPT produces dead load and live load, but the imported loads are actually called dead and live. So there's a little bit of a nuance there. To avoid confusion, I'm going to turn off the reserved load cases in ADAPT so that we don't have any duplication and it doesn't cause confusion when we're assigning factors into load combinations or solving for combinations. So those are general loads that are assigned as gravity, and then the applied story forces, those applied lateral loads, are defined as building loads. So in Builder, when we solve for either native lateral loads that are produced inside of ADAPT-Builder, or if we solve for imported lateral loads, which we've just done from Etabs, you have to assign those as, or I'll say this, you have to solve those within global building mode in the program. They are not solved for at a single level. They're always solved for when you run the entire structure analytically in Builder. So those are building loads. And you can see there's EQX, and we run through that entire list of the wind forces or the wind loads also. Going back to loading, and if I go to add load and I go down here all the way to the bottom for lateral loads, this is a generic way to input lateral loads in the program. We have explicit methods for doing wind loads using the wind load wizard or the seismic load wizard. But if you wanted to just input a story force, the program will accept that story force, and at the onset of global analysis in Builder, the program will take that story force and it will divide it into nodal loads, whether it's a moment or a force at each node, and it's dependent on the shell element or the frame element mass relative to the total mass of the floor that's in question. So that's how the loads get distributed into the diaphragms when we analyze the structure. If we go into the lateral load wizard, you can see that all of the applied loads, because I chose to import them into this model, those are all listed here. So we have EQX, EQY, Wind, and WindX and WindY 1 through 12. And for any of those load cases, the program brings in the story forces that were written inside of Etabs. Plus, you have that assumed eccentricity that is that was assigned in the import options. Here, you can override that for any of the lateral cases. At the bottom of this window, you'll see there's a seismic mass. So we can assign this seismic mass. This is really what we originally developed for seismic loading in the program, where we allocate the force at nodes relative to the mass, but we extended it to this generic lateral load input as well. So the lateral load input doesn't need to be a seismic load. It could be any lateral load that you wanted to include here. And let's go ahead and close that. I'm just showing you where the applied loads that were imported in are stored if you wanted to rerun those. And we'll go ahead and close that. And I'll go to a default view. Now, if I go into single level mode, let me just navigate down towards the bottom story here. And using the result display settings in our program, because I've imported in a set of reactions from Etabs for all of my different load cases, I'm going to focus on a couple of perimeter columns for an example. If I look at this case box at the upper right of result display settings, we already have reactions that are sitting off in a file in the background somewhere where we can pull in these reactions into either a graphical view, or actually we can use them in a rerun of a floor. So if I go ahead and pull this button down, you can see this lists every single load case that was imported in from Etabs, and it says the source is Etabs. It's a global solution from Etabs. So, for example, if I select dead load, this is the superimposed dead from Etabs, and I turn on the column axial forces for load case. That's important to differentiate between combination and load case. The load case axial force due to the Etabs reaction for dead are shown here. So at the bottom of the column, it's 327.8 kips. This is the reaction from the global analysis in Etabs. And you could do the same for any combination. I could come down to wind x6. There's the axial force for wind x6. I could look at moments, shears, whatever action I wanted to review. Those are stored reactions now in Builder. And we can use them for specific things. For example, I mentioned earlier being able to use these reactions to process the design of a mat slab, for example. Just to compare results, what I'll do is I'll go back into global mode, and I'm going to run our tributary load generator in Builder just to compare the geometrically based tributary load takedown inside of Builder with the axial force that was calculated inside of Etabs based on a finite element solution in Etabs. So I'll go here to loading, tributary loads, and I'm going to regenerate my tributaries. I'll just recalculate the loads. Let me just go back up to the top to kind of familiarize you with this tributary tool. Once I've generated the tributaries, I can scroll down in the display settings, and these red regions are my tributaries. So the program, for example, for this column and this column, there's a tributary that was calculated based on these boxes that I'm highlighting. For this wall here, the tributary looks like this. This zone. For this wall, tributary looks like that. That's what the program has determined based on. This is not based on stiffness of the components. It's just based on a geometric function that we use to calculate these regions. So let me go ahead and delete that. So now I can turn on the cumulative loads. So the program is using the applied loading that we brought in from Etabs, and I think it was 10 PSF for dead load, 40 for live load. And if I navigate down the building, right now I'm on level 8. If I just scroll down the building, let me zoom into one of these columns, you can see that the self-weight, the dead, the live, those start to grow because it's showing you what the tributaries are cumulatively through the height of the building. And down at the base of the structure, we have, for example, a tributary-based dead load. By dead load, I'm taking the superimposed and the self-weight of 28.3 kips plus 318 kips. So we get around 346 kips based on load takedown, tributary load takedown. If I compare that to the finite element-based solution in Etabs for dead and live, or excuse me, for dead and self-weight, if I go over here to dead load again, this is the dead load from Etabs. This includes self-weight. This is a multiplier of 1 that's specified in that program. If I go here to column, again, axial force, the axial force is 327. That's the finite element solution from Etabs. The tributary solution in ADAPT is, I calculated as 346. It's just dead plus self-weight. So you can see they're pretty close. I mean, they're off by 5–6% for this particular column. That's one thing you can do just to validate, kind of feel good about what the solution is you're bringing in from Etabs and what a simplified tributary takedown will give you in Builder. Now that's just one tool that can be used in Builder. That's purely, again, based on geometry. It has nothing to do with the finite element solution within Builder. So one of the ways you can use the data that's imported from Etabs into Builder is being able to reanalyze the frame inside of Builder using the applied loads coming from Etabs. There may be reason to do that. Maybe you want to compare frame results between both programs, so using the same level of loading. So to do that, what we need to do is go back to our multi-structure mode. Remember, building loads are only solved for when we're in building mode or full structure mode. And under load combinations, we imported several combinations from Etabs. But what I'll do is let me just delete some of these. These first 5 combos were just the default combos inside of Builder, so I'm just going to delete them. We're not going to use them here for our condition today. I'm going to go to the bottom of this stack. I'm just going to add a couple of combos just for the sake of producing a result using the applied load. So we'll just do 2. We're going to say we'll call this test 1 and maybe test 2. So for test 1, we'll say test 1, and you can see this keeps refreshing, so I'll sort that by cases only. There's a lot of cases that we brought in. So test 1, I'm going to say is just EQX. Test 2, we'll say is wind X1, let's say. And we could assign factors for any of these imported lateral load cases to any combination that we're producing. So these are just simple tests we're making to show that the imported applied loads can be rerun inside of Builder. And I could apply factors to my gravity loads. Self-weight, that's native to Builder. We're automatically calculating the self-weight of the structure just based on its geometry and volume. The dead and live loads, those are externally applied loads in Builder, but they stem from the import from Etabs. So we're only going to produce a result for these 2 lateral loads independent of any gravity load. I'll just say OK. And now if I go over here to FEM, I'm going to mesh the model. So I'll mesh this at something relatively high, 5 feet. Just produce a faster result for us. So this is just cycling through each level, creating a mesh for each unique level. I'm going to save the model. I'll just call this model 1. And now, because I'm in multi-story mode, if I go to FEM Analyze, you can see I can select from any of the combinations that I've included in this particular model. I have these 2 test combos at the bottom. One thing to note here is there's the options to include reactions is grayed out. It's inactive because we're running the model globally. We can't include reactions in a global model. We can include reactions in a single level model, which is one of the other workflows that we'll show. Also to note, the program by default is using the uncracked condition of all components. So I could go in and create a usage case. I'll just show an example of this. If I double click on any of the components and select stiffness modifiers, the default is uncracked, so that cannot be edited, but I can go ahead and add a new stiffness. I'll call it stiffness 50%, let's say. I'll say OK. That's added to this list. And I could set the stiffness 1 by 1 for each component, but that would take too long. It would be inefficient use of time here. So what we'll do is we will globally just select our components. So let's say we wanted to reduce the stiffness of the columns for some reason, or the walls. We'll just do the columns in this case. And I'll select by type. I'll go to the option to select by type, columns, and I'm going to modify those columns. So I'll go into the column tab under the stiffness modification, and I'll set these to 0.5. And you could set up multiple stiffness modifiers. You know, I could have multiple usage cases. Here it's labeled usage, so we'll say usage case. And I could set up more than one, but here we have just one, for example. Now when I go back to rerun the model using the applied lateral loads from Etabs, if I go back to analyze, the the program now gives me the option to use uncracked, or I could use stiffness 50. So this will list all of the usage cases that could be selected from. And the program also retains and stores the solutions, more than one solution. If you run 5 different usage cases, it will store reactions for all 5, similar to how it stored the reactions for the imported Etabs solution. Okay, so we'll select, we'll deselect the vibration analysis and go ahead and run the model. So if there are any questions while this is running, this should take just a minute or so. This is a good time for questions if anyone has anything they wish to ask. Otherwise, we'll just go and take a small break here. One thing I'll make mention of, you'll see this analysis window. This is internal to a build I'm using, so it's really meant for debugging. On your end, if you have the software, you're not going to typically see this particular window. And we'll say OK to the solution. Now I have a solution in place for, I think it was test 1 was EQX. So we can actually compare results between an Etabs model and a builder model if you wanted to compare the solution. And assuming that they're apples to apples and the stiffnesses are the same, there's no modification in one versus modified in another. So looking at, and the comparison can be done using Builder if needed. So if I rotate that model just so I can see these columns again, I'm kind of focusing just on column moments because it's a little easier to see than the wall stacks. But if I go back to my result display settings, test 1 is 1 times EQX. So I'll go up to column again, and in the column tab, I'm going to select under action for combinations now, not load case. For combinations, we're going to do moment about the S-axis. And at the base, we have a moment of 214.2. That is the solution derived from Builder's frame analysis. If I look at the reaction, so that's 214. If I go back to the reaction for EQX from Etabs, this is EQX Etabs global solution. And if I turn on the action load case under moment about S, you can see here that there's some load case shown here. Now, these look like they're pretty far off. I don't know why. I would have to investigate that, but that shows the reaction from Etabs, whereas test 1 would show the solution that was stemming from the frame analysis in Builder. Make sure I have the right combination in here. So we'll go to load combos, FEM, and test 1 was EQX. So the results should be pretty close, depending again on how the models were set up. I'm not exactly sure why those results are so dissimilar, but that's something that we can look at on our end. But that just shows you the usage of the rerun of applied reactions, or applied forces rather, in Builder. So another potential workflow is to rerun a single level using the reactions from Etabs. So let's say you run a lateral model in Etabs and you have a post-tension slab laid out in Builder. And it might be a single level slab. So we'll go here and we'll navigate to the 4th floor in this case. And in this model, the assumption here is that we laid out the gravity loads inside of Builder. So let's say the dead and live were just modeled in Builder as just patch loads or uniform loads. We might have point loads and line loads, whatever, just gravity loads. And we also have post-tensioning. So if we had PT laid out in this slab, then the goal might be, well, I want to be able to produce strip results for both the gravity loads, the effects from the post-tensioning, and also my my reactions, my lateral reactions that were imported from Etabs. This is one of the more viable workflows and more common workflows that we would want to use in the software. So what I'll do is just go ahead and model my design strips just to get something in place here. So I'll use the support line wizard to model these. So we'll focus on the X direction, let's say. We would do the same thing for the Y, but for the sake of time, we'll leave that alone. And I'm going to create my strips. Try that one more time here. Miss snap there. So I have 4 design strips, and I'm now going to just create some post-tensioning in those design strips just to have some PT here in this model. So we'll go to the tendon toolbar. I'll map tendons to these design strips, and I'll just use the defaults here. Let's set the spacing at 1 foot. So I need to delete these tendons at the sides because they're outside of the slab, and by doing that I should increase the count here by a factor of 2 because I deleted 1 row of tendons. So we have some tendons in the slab. If we were to look at this slab in as a side view here and maybe scale it, use actually let's go over here to the rendered view. I'll turn off the walls and columns and show this way. So I'll use a factor of 3. So these are the tendons in the model. Once I get the model back, those are just some banded tendons. They have curvature. There's some forces happening because of the PT in the slab. So we have gravity load, PT, and we also want to apply forces due to lateral from this on this slab. But I have a lateral solution already from Etabs. So what I'll do is I'll go to FEM. I'm going to analyze, and let's say I want to evaluate a combination that includes a lateral load. So this UD Wall 8 is dead load, live load, earthquake load. It doesn't have any of the post-tensioning forces associated with it. So we'll go back to load combo. And remember, these were imported from Etabs, so that we didn't have any PT in Etabs. So I need to adjust the combination here. So this is a factored. I'll use hyperstatic, 1 times hyperstatic, and I'll do 7 and 8. These are designed, let's say, ultimate combos that we want to design for. So back in single level mode, I'm going to analyze the structure for UD 7 and 8. And if I analyze it as is, as using what I've selected here, program is going to apply dead load and live load because those are applied loads on the slab. It's also going to apply the hyperstatic. It will solve for the PT now in the slab. But it doesn't, we have EQX assigned here, but it doesn't know what to do with EQX because I haven't told it yet how to handle EQX. So I want to, on top of this, I want to also include the lateral reactions for EQX. So it knows, okay, these 2 combos that are selected include EQX, pull EQX into this box, and I can specify the source of the solution for the reactions pertaining to EQX. So I have EQX, the source is actually Etabs. If I solved EQX using ADAPT's native engine for frame analysis, I could also use that solution. So I already had solved EQX in the previous run globally, so you can see here that not only does it list Etabs' solution, but I can use ADAPT's solution as well in the rerun of the floor. But I'll use Etabs here given the workflow we're looking at, and I can then rerun a single level with lateral reactions with native or imported gravity loads and also post-tensioning in this one level using this tool. And that analysis is done. The next step in this particular process would be to generate the design cuts. I think we've already done that. I'll just do it again. And then we're going to design the design cuts. Okay. And for those two combinations that I processed, wall 7 and wall 8, you can see that the program produces, so like for example, bending actions along the strips. These are the bending diagrams relative to that combination, which included several sources of load case solution to it. And ultimately, we might want reinforcement for the slab relative to those combos, so we could go ahead and generate rebar for the envelope of that set of combos. Now it says no rebar is needed. We have PT in the slab, so the PT satisfies the requirement for the reinforcing in the slab. Okay, so that's the second workflow. Now the third workflow would be to just build on top of this, and that would be to design columns using the same set of forces. So at a single level mode, I can design columns due to the rerun of the floor. And what I would have to do in this case is, if I double click on a column here, you can see that the column has no section type assigned to it. So I'm going to assign a design group for the columns in the model, and the design group can be flexible in terms of what columns are assigned to the design group. I could assign a design group to every single column individually, or I could select specific columns to design. So I'll go back to my two edge columns. These are kind of interior edge columns. That seems like an oxymoron, but these are the corners, these are interior. So I'll do these two columns as their own design group. And we'll go to modify the properties of these columns that are selected. We'll go to design group. I'm going to auto assign a new group to those columns. So once I auto assign that new group, if I double click again on the column, the group that the program created was 21.99 circular. So these two columns are that particular group. If I go back to build section type manager, that group gets added to this manager. Now I can go in, and I don't like the 21.99 is a little too exact, so I'll do 21 circular edge interior, just to specify what column group it is. I can then determine and fill out some of the values relative to that particular column. Here the pattern is square. I want to make the pattern circular, so I'll go and just adjust the vertical bars. And we're going to say we'll use number 8 bars here. Let's make sure we select the right pattern. So the shape is circular. Let me see the splice type. Yeah, here we need to change this to circular. So we'll use number of bars in the first layer is 5. If I increase this, for example, to 6, that just increases the number of vertical bars. So we specify our design group. We set our settings here in terms of the ties and the vertical bars. And now we can either code check the column, or we can design it based on the solution that we just ran, including the lateral, the gravity, and the hyperstatic effects. So I'll set that as those settings, number 8 bars. We go over to FEM, component design options. This is the column design options essentially. We just produced a result for these two combinations, wall 7 and wall 8, which included native loading inside a builder and also reactions imported from Etabs. the force source that we want to specify is variable. You can use the FEM solution. We just ran an FEM solution. We had meshed this single level and ran this solution. So that's the current solution in place. We could use a tributary method, which means we only take in the axial forces into the columns. And that tributary solution is also in place, but it's based on that first tributary run that I had made to show the difference in the axial forces between the Etabs finite element solution and Builder's tributary solution. So we're not going to use tributary. And then we have other options for enveloping tributary and finite element. So we'll say we're going to use ADAPT's finite element solution. The source is level analysis. We just ran the single level analysis, so that's the solution source. The hyperstatic source, the secondary forces from the PT that we want to pay attention to in the design, are also governed by hyperstatic. And then we have additional selections here that are more design-oriented: design code, minimum moment, slenderness, and design constraints. So I'll ignore that for now. And we've set up the ability to now produce or code check these two columns relative to, again, the imported reactions from Etabs and native loads in Builder. So we'll take this the next step. We'll go back to FEM, and I'm going to just design and code check. I'll code check these two columns. So I only have two columns specified, these two, and those are set to this particular design group. I'll say OK. I want to code check the columns. This requires a link with S-Concrete, so a license of S-Concrete is necessary to do the code checking or the design of the columns. Once this is completed, the program will allow the user then to view the results in a file format or graphically. So if I go and I click this column, right-click, look at the design summary for that particular column, you can see the summary sheet for the column design. This is actually produced by S-Concrete, but it's launched inside of Builder. And this column obviously doesn't work for various reasons, it looks like. This is a tabular report relative to the design. And then if we were to go back and code check, or excuse me, graphically check the results for the column, we could always go up to the column tab here. For individual column design results, I'll look at the status, and this just shows me some graphical solution for those columns that were designed. So the point of this is, again, we can utilize the Etabs model and some of the reactions and solution from that model and incorporate it and combine it in Builder by use of the integration console. So that's what we had prepared today. I'll stay online here for another 4 or 5 minutes. If anyone has questions, you can type it into the question box. I appreciate everyone's attendance. Again, this will be placed on our YouTube channel under the ADAPT webinar playlist. And at this point, we'll just conclude and, again, open it up for some questions if you have any. Okay, looks like there are no questions. So if you do have questions after you have had a chance to think a bit about the webinar and what was presented, please feel free to contact us at support@adaptsoft.com. Thank you.